In today's video, I'm going to look at this integral from 0 to 7 of x squared e to the negative x dx. We're going to have to use integration by parts, spoiler alert. So without this prompt of integration by parts, here's what you would probably think. You're probably thinking substitution in some way. So you'd say u is equal to negative x, and then du is equal to negative 1 dx. It doesn't work. Doesn't help us, because we'd want something to substitute out, and then it would have to replace that x squared, but it's not working out that way. So we have to use integration by parts. So that's why there's that prompt of using integration by parts there. So in integration by parts, there's a lot of different rules and ways to formulate like which to set your u and everything. But the u here is going to be the algebraic statement of x squared. So I'm going to set u equal to x squared. That means our dv is going to be e to the negative x dx. And so when we're doing integration by parts, you got to remember that you're taking the derivative. So the derivative of that term is going to be du, and then dv, we got to get to v. And the whole goal with integration by parts is you're going to have uv minus the integral of v du. And the whole goal of that is for this term to be something that we could actually integrate. That's the whole reason we have integration by parts. And then hopefully that works out. Now, if it doesn't, then we got to keep working through that a little bit more. So let's check out what happens here. So u is equal to du, u and then du is equal to 2x dx. And then dv, that's going to be v, that's integrating dv. So let me do that off to the side here. So I'm going to take the integral of e to the negative x dx. So in order to integrate that is just really just knowing how to integrate exponential functions. And the rule there is it's just going to be negative e to the negative x. Like it's e to the ax becomes 1 over a e to the ax. So in this case, it's negative 1. So negative e to the negative x. And then now let's put everything back into the integration by parts. So uv, so x squared e times e. I don't like how I wrote that. So x squared times negative e, so uv. So I'm going to just put the negative out in front there. E to the negative x. That's uv. Minus the integral of v du. So it's going to be negative e to the negative x times du, which is 2x dx. And I know I wrote that kind of weird, but just trying to save myself a little bit. So now let's rewrite this. Two things I could do here. First thing is I can, this minus sign here, this could come out. This is going to become plus, which I'll change. This 2 can also come out. So let's just go ahead and do that, I guess. So I'm going to have negative x squared e to the negative x plus 2 integral of e to the, let me actually write that as x e to the negative x dx. All right, so let me just recap that again. I took this negative, brought it out. That became negative and negative, which makes it a positive. 2 came out. So now I have this integral of x e to the negative x. Remember what I said over here. Our whole goal is for that term now to be something that we can integrate without having to use integration by parts, like substitution or anything else. Can I do that with this problem? No, not yet. Because if I try to use substitution, same thing as I started this video off with, you'd set your u equal to negative x, du would be negative 1 dx. I have this x causing some issues, so that's not going to work, which means we have to use integration by parts again. We got to do it 2 times. So I am now this is going to get really messy if we're not careful here. So this is going to come down. Now I am performing integration by parts on this now. So I'm doing integration by parts twice. So let's I'm going to do that over here. So integral of x e to the negative x dx. So I'm doing integration by parts again. So u is going to equal x. dv is going to equal e to the negative x dx. The integral of, the derivative of u, du, that's going to be 1 dx. dv, that's the integral of dv, so that's going to be the integral of e to the negative x. I already talked about that back in our original dvv. That's just going to be negative e to the negative x. So integration by parts, uv, so we're going to have negative x e to the negative x minus the integral of v du. So v du, which is just dx. It's 1 dx. So now let's stop, take a breath, and take a look at what we have here. We have the integral of negative e to the negative x dx. I'm going to take out that negative, and then I just have the integral of e to the negative x. So boom, we have it. We're good to go. So there's a lot, though, I got to keep track of, because first of all, I have this 2. See how I took out that 2 originally right here? So this is 2 times all of this. All of this is what's in brackets, because that's integration by parts. So we have to be careful. Let's just finish up this portion, and then we'll deal with that too. So I'm going to have negative x squared e to the negative x plus 2 times negative x e to the negative x plus the integral of e to the negative x dx. All right, let's keep going. So now I'm going to integrate this. This is just going to be negative e to the negative x. We've done that integral 3 times at this point now. Well, this is the 3rd time. So I'm going to have negative x squared e to the negative x plus 2. And I'll deal with that 2 in a second. I don't want to do too much in one step. So negative x e to the negative x minus e to the negative x. And don't forget, now that I'm thinking about it, look at this. We still have to evaluate this. So we are not out of the woods just yet. So this is all from 0 to 7. So now I think would be a good time to let's just distribute this too so things don't get too complicated. So that means, let's go blue. So negative x squared e to the negative x. And this is 2 times negative x e to the negative x, so that's going to be negative 2x e to the negative x minus 2 e to the negative x from 0 to 7. See that? So again, 2 times negative x is negative 2x. 2 times negative 1 is negative 2. So that's how I'm getting those 2 terms there. So now you want to plug in 7, plug in 0, and really be careful from there. So we're going to have negative 7 squared e to the negative 7 minus 2 times 7 e to the negative 7 minus 2 e to the negative 7 minus, now plug in 0, negative 0 squared e to the negative 0 minus 2 times 0 e to the negative 0 minus 2 e to the negative 0. So just to save myself some time, I'm going to go ahead and just plug this in my calculator and then show the answer here. So if you want to try this out, go ahead, pause this video and try it out in your calculator, see if you're getting the right answer. But I'm going to go ahead and move forward with writing this answer down. So what you should get after you go through all of the button hits is roughly 1.94. Really good exercise there in everything. This is a really, really involved problem. A lot happening. We have integration by parts twice. We have also the fact that we have to evaluate from 0 to 7. a lot is being thrown at us this problem. Like, this is the type of problem that if you can really wrap your head around, if you can master this type of problem, then I don't see integration by parts being much more difficult in whatever class you're taking. But this is a really good problem that you definitely want to master and really understand the ins and outs of all of this. So hopefully this video helps you with multiple integration by parts problems.